All right, these next two lessons in Unit 5 go over different types of reactions. All right, so in this lesson, we are going to cover the first three: synthesis, decomposition, and combustion reactions. And your goal is to be able to, from a list, identify a reaction as one of these three, and be able to balance them. So, a synthesis reaction. If you think about that word, you may also think of the word like synthesize or synthetic, all right? All of that has something to do with making, all right? So in a synthesis reaction, you are going to take two smaller substances, oftentimes it'll end up being two different, like, pure substances, and combining them into a compound, all right? So you can really think of it as two reactants get smushed into one product, all right? But this basic generic equation, definitely something you want to write down and be familiar with. So, this is where some practice comes in handy. Pause the video for a second, see if you can figure out in both of these groups which one is the synthesis reaction. All right, and then start it up again. Remember, the basic generic equation is you're going to take two separate substances and smush them together into one single substance after the reaction. All right, so if I were to, say, narrow some things down, I want two reactants. I need to have two separate reactants. So that automatically gets rid of A, because that only has one reactant. The rest of these all do have two reactants. But the next thing I need to look for is having a single product. All right, and C and D have two products. So I can cross those out. All right, so B here is my synthesis reaction. It has, you can think of it as this is A plus B, and that's AB. All right, so in the next one, let's see. Everything in here has two reactants, so I can't use that to narrow things down. But if I look at my products, these first three have two products. It's this last one that is the only one that fits this. A plus B makes AB. All right. Decomposition, if you remember from biology class, a decomposer, all right, those are organisms that break things down, and that's exactly what a decomposition reaction does. All right, so decomposition is the exact opposite of synthesis. All right, so you are going to have one reactant making two products. They're being split up into two separate products. So oftentimes you'll have a compound that is split into its elemental pieces. All right. So pause the video, see if you can spot the decomposition reactions in these samples. All right, keeping in mind that we need to match this format, one reactant being split apart into two products. All right, kind of makes it easier to spot these because, let's see, that has two reactants, that has two reactants, that has two reactants. C is the one that matches this format. AB, A plus B. All right. So looking at the next one. Two reactants, two reactants, two reactants. A has got to be it. Here's your AB, A plus B. Okay. All right, so real quick, a balancing one. See if you can get this one done right on your own. But before we start the balancing, what type of reaction are we dealing with here? I hope you are saying that this is decomposition. So we have one reactant being split apart into two products. All right, so sodium, 1 and 1, 1 and 2. Fix the chlorines, but let's put a 2 out front on this side. But that's also going to double my sodiums. So I'll have to put a 2 here to get that to match up. All right, this should have been a fairly easy one. If you find you are still struggling with these, come see me. All right, so a combustion reaction is a little bit more complicated than the other ones, but it's something that you probably have a better familiarity with, because if you've ever ridden in a car that runs off of gasoline, the reaction that takes place in the engine is a combustion reaction, right? If you've ever sat at a campfire, right, the reaction that's taking place is a combustion reaction. All right, so combustion reactions have a little bit more specificity to what goes into them. Not any element can be present here. So in some ways, it almost makes it easier to spot a combustion reaction. All right, so a combustion reaction is always going to have a carbon-hydrogen compound. The only thing that can change is these numbers here. It could be CH4, it could be C10H45, whatever. Some combination of carbon and hydrogen. Then the other reactant absolutely, always positively has to be oxygen. All right? So if there's no oxygen as your second reactant, this is not a combustion reaction. There's also your products absolutely positively have to be carbon dioxide and water. All right, so really the only variations that we have in here is this first compound, which will have to have carbon and hydrogen in there, but it can have different numbers of carbon and hydrogen. All right, so see if you can spot the combustion reactions. All right, remembering that our reactants have to be a carbon-hydrogen compound. The numbers following carbon and hydrogen are not necessarily determined beforehand. And you have to have oxygen in there. And then your products have to be carbon dioxide and water. All right. So let's see. There's no carbon or hydrogen here, so I can get rid of that one. We've got hydrogen, but there's no oxygen, no carbon dioxide and water, so we can get rid of that one. All right. So I've got carbon and hydrogen compound. Good. I've got oxygen as my other reactant. That's a good sign. Got carbon dioxide and water as products. So C is your combustion reaction in this first group. And the next one. Ooh, this caught my eye. I also have water here, but why isn't this one a combustion reaction? What's missing? All right, there's no CO2 or CXHY. All right, so that one, not combustion. All right, the one above it, no oxygen, no carbon, no hydrogen. The top one has no carbon. It's got oxygen and hydrogen, but not in the format that I need them to be. And then here's my CXHY. Here's my oxygen, and then CO2 and H2O. So B is the combustion reaction there. All right, I want to answer this question because I know you will see something similar to this on the unit test. So combustion reactions, if you think about it, combustion reactions fuel your car. Combustion reactions give off heat when you have a fire. So like, what else is being released other than the oxygen in the water? You might be thinking heat, all right? Might be thinking light. Those are all forms of energy. Write that down somewhere. Keep this in mind. You don't see it in the reaction, but it is released. The reason why you don't see it in the reaction is because it's not a chemical, right? Energy isn't matter. So it's not going to have a chemical representation in a chemical equation, okay? All right. Wanted to go over balancing combustion reactions, just because these are a little trickier than the other ones, in the sense that you got to be really careful about the fact that you have oxygen in two different places in your products. All right, so when creating your table, you have carbon, hydrogen, and oxygen. Carbon, hydrogen, and oxygen. All right, got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 2. All right. 1, 2, 2, and a third oxygen. All right. So that's the first thing, is make sure you get all the oxygens counted initially. My next suggestion is that when it comes to balancing, deal with oxygen last. Because it's hard to tell where should I start making some changes on the product side, because it's in two different places. All right? Whereas carbon and hydrogen are in one single spot. So fix your carbons and your hydrogens first. So to fix carbon, I'm going to put a 7 out here. All right? So that'll give me 7 carbons. And that's going to give me 14 oxygens plus the one over here. Don't forget that one. So that's going to be 15 total. All right. So, carbon fixed. Next, I'm going to fix my hydrogens. I've got 16 on this side, and I've got 2 on the other side. If I put an 8 out here, that will get me up to 16. All right. So now hydrogens are fixed. Except I'm almost forgetting something here. What am I forgetting? Hopefully you're saying something about, oh, you got to fix your oxygens. All right, so I've got 14 from the CO2, and then 8 from the water, so that makes 22. So there's 21, 2. And now I can fix my oxygen issue. All right, so I've got 22 on the product side, 2 on the reactant side. If I put an 11 out front, that's going to give me 22 over here. All right. So that is my advice to you if you have to balance a combustion reaction. Fix carbon and hydrogen first, deal with oxygen last.